Nice. All right, checking mic. Looks good. Welcome. We're going to be unboxing a USB-C counter module that we ordered a while ago. I didn't actually prep that much. Let me see. Let me see if I can get my chat up just to make sure I have it. Cool. Okay, looking good. Yeah, it's been a while. I haven't done a lot of live stream development. I've been chilling. But yeah, it's always a calibration. You do a lot start of Hacktoberfest, then you calm down. I also notice when I start doing it again, it's never like the early morning time. I kind of hit this midday time that kind of works for no one, but that's fine because this is an unboxing stream, so it has some repeat watch quality. So maybe somebody later will watch it. But anyway, let's get right into the unboxing. Turn on camera 1. Is this camera 2? Well, we can start with camera 1. Okay. So this is a USB-C, or it's supposed to be a USB-C counter module. It actually doesn't really give me that much information, so I kind of don't know until I open it up. So hopefully it's not something I don't want it to be. Something boring. But yeah, let's see what's in here. Okay. I have a giant stack of trash next to me because I have nowhere to put all this stuff in my tiny San Francisco apartment. I'm probably going to move into a smaller space too. And then look for just like try to spend less on the home and more on the lab. But we'll see how that goes because in San Francisco, everything is expensive. So, all right. So as usual, we've got, oh, weird. Oh, they attached everything this time. So normally they don't do this, but we have some populated, some unpopulated. So let's snatch out one of the populated ones. And then let's see if we can pull up our close cam here to actually look at what's on this board because it's pretty cool. But yeah, we're gonna want to get a close cam for it. All right, a little bit of trash cleanup. Then let's go over here. Let's see how we can get this thing to turn on. I have a lot of cameras, so I'm not really 100% sure what turns on what. Oh, this is the wrong microscope. Yeah, this company sent me so many I lost track. Okay. All right. This is the one that works. Okay. Yeah, there we go. All right. So this is our microscope. This might be a little bit too zoomed in. Yeah, this is a little bit too zoomed in. Let me see if I can do any better. Nah. Yeah, I don't really have a great compromise here. I do have a second camera I can pull closer. Let's see what I can do. I'm also wondering how many cameras my PC can handle. Okay. That's not the right one. Maybe I can't handle this many. All right, we'll just be lazy about it. I'll use an existing camera. Okay. Oof, that's really tight in there. Oh man. All right, good enough. So this is the module, and basically conceptually, you have USB-C power here. So we'll plug that in a moment. And every time you press this button, it's supposed to increment an LED. So this is basically a demonstration of a counter module, a TTL counter module. So the other interesting thing about this circuit is this was designed by AI. I didn't check anything. I literally did not check the data sheet or anything. AI spit out this board, and all I did to change it was added some resistors. But actually looking at it, I think you could have gotten away with not adding them. So it's essentially a fully AI generated board. So if we go into debugging, we'll pull out the scope, but otherwise we're just gonna assume everything works. Oh boy, I'm wrecking everything. Oh, oof, I didn't need a lab setup so bad. Oh, okay. All right, I'm gonna try not to break anything else. It's like no better. All right, anyway. All right, so let's plug this guy in and see what happens. Super simple. We're doing simple ones to start. We'll get into more complicated stuff. I got to fix my camera setup. Everything is falling apart right here. All right, I'm going to take 5 seconds to rewire everything. Wow. All right, that's a little bit of a better place. Got this guy basically mounted above the microscope. Okay. Yeah, so let's plug it in. I'm also going to have to shuffle some wires into this. Okay. So we need a USB-C to C adapter because we need to power this guy with USB-C. So I think I can use the same. We learned last time not all USB-C connectors are created equal. So I think I have one picked out here that will definitely work. Let's see if I can find it. Okay, here we go. This worked on our flashlight, so hopefully it works here. I don't know if anything will happen when we first plug it in. Maybe nothing will light up. Okay, I heard a snap, so I think it's in there. Although that wasn't very pleasant how it went in. All right, so I'm not seeing anything on this, so I don't know if the AI designed this guy right. That snap is uncomfortable. It's like this loud snapping sound every time it goes in. But it looks like everything is on there okay, so I don't know. Maybe it's just this port. I feel like I didn't hear that on this one, though. Nah, it's got the snap. All right, fine. Everything's got the snap sound. Yeah, actually, maybe we just verify this guy's got power. So we plug in our old chip. Okay, so this one still works. But this one is supposed to do things and it's not. So let's pull up the design and see if we can figure out why this thing is not working. Okay, so this is the board in TS circuit. And yeah, what's supposed to happen? So one side of this button is connected to ground. That's a little weird. And this side, okay, I think I understand. Maybe. So one side is connected to ground, one side is connected to the V bus of the USB. Okay. So this pin is power, I guess, for the counter chip. You know, that's a weird pin to be power. Usually power is pin 1. So that's something to check. This guy's ground. Okay, sure. I wonder if this schematic view. Yeah, schematic view is a little bit bad looking right now. So it's hard to validate. Let's try doing auto layout. Yeah, it's not really working for us. Ooh, yeah, this is pretty buggy. So we're kind of stuck with just the PCB. I guess the first thing I'm curious about is, are we powering this chip properly? So I guess we'll look at the data sheet, just do some general debugging. We pull in this chip, the central chip, from this TTL counter module. So this is just the chip now. And I think this was imported from JLC. So maybe it's good. But we'll need to do some debugging on it. Okay. So let's grab the JLC PCB part number. Oh, wow. That does not come up quickly. Usually JLC part numbers come up pretty quickly in Google, but that one's not coming up. They do have a part number search though, so we can just use that. And then we have a data sheet. Okay, so it does look like pin 5 is actually VCC. So yeah, a little bit not what I would expect for powering it, but it does look correct. Okay. Yeah, so I guess now we got to do the work debugging AI, some AI generated code. What did it do wrong? Okay, 3-stage binary counter. Okay. I might need a reference circuit for this. It's not like it's super complicated, but I kind of don't want to have to think super hard. Yeah, this might be the most interesting diagram because it kind of tells you a little bit about how this works. But let's take a look. There's a lot of things that could be going on. So first, let's take it step by step and make sure that this pin is powered. And then I kind of want to check also that ground is good. So pin 10. Is that labeled properly? Pin 10. So this guy, pin 5 is power, pin 10 is ground. 8, 9, 10. I think these all got labeled properly. So, yeah, I don't know. Let's put it under the scope or the microscope and see if we can do power. If our microscope works. Oh. There we go. Just have to switch it on and switch it off again. Love it. Oh, trash everywhere. All right, let's get to it. So we want to see where our power is going on this board. So I'm going to put I'm going to try to fixture it such that the chip is under the microscope. Yeah, like that. And then we'll get pin 5 there. I wish this guy wasn't so close. I might be able to bring it a little bit further away. I'm going to try something. This is very sketchy, but I might be able to get it to work if I just screw this in really tight. It's very sketchy. Yeah, perfect. All right, cool. So that's a little further. Okay. Let's bring it into focus. Still a bit too far zoomed in, but whatever. Okay, so we already have the USB drive in there. So I guess on one of my screens, I'm going to be looking at what I need to connect, and then I'll just show the scope on stream. That's probably the easiest way to do it. I need something that acts as ground. I think I'll do pin 10 on the chip. That should be shown. So. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we should be getting a 5-volt signal. We're not. Oh, no, we are. 5-volt signal. Okay. So the chip is being powered. So we could how this the basic concept of how this works is the button is supposed to send a clock signal over. That's why I kind of paused on the frequency or the kind of the signal diagram part of this data sheet. Let's go over to that, and then we'll rotate the data sheet until we can read it. Yeah, so basically, what are we signaling to? So switch 2 goes to ground. And then this side goes up to CKA1, CKA, which I think is probably clock A. So there's clock A and clock B. So the idea is clock A is going to go up and down, and then these other things are going to start counting. Okay, output QA1 and clock B input. Well, anyway, let's take it one step at a time. So let's test that the button input is actually going to that pin properly. So this goes to pin whatever 14. So we'll want to look at pin 14 and see if that is going high when we press the button. Okay, so this is pin 14. Okay, that's pin 10. And now we just need to press the button with my finger. Okay, so little weird. I get that this is normally 1.2, and then when we hit the button, it goes down to 0. So it's 1.2. Actually, it's a little inconsistent. Yeah, when I press the button, it gets driven down to 0. So why is that happening? And is it supposed to happen? Kind of a rare position where you don't know what your circuit is supposed to do because you generated it. I don't think it put a lot of logic in the code. It didn't really explain itself. It just added all these traces. These might be easier to read than the PCB. So like, you know, you're saying, okay, power goes to USB-C pin 13. Okay. That makes sense. That obviously worked. Ground goes to ground. That probably worked. So this guy is being pulled down. That makes sense. So ground is connected to one pin, and then the other side is connected to man, I think the AI might have flubbed this. So like one side of this button is connected to ground, okay. But it only like that means the chip is only powered when you press the button, if I understand it correctly. Like chip's not powered. There's no path to ground except through the button. Oh no. Actually, no, that's not right. The button pulls clock to ground. So I think maybe the clock pin needs to be pulled up, unless it's pulled up by default. Let's get an example of this guy. Example circuit with, you know, first glance, this looks very similar. think I just need like a schematic, really. Okay, somebody made a schematic here.
In this video,
That looks like a different chip. I don't know. Because we have like clock A, clock B. This is a really old chip. A lot of people would know how to do this like the back of their hand, but I do not. Okay, I think this is all mechanical stuff. So it's really all in that first section. Looks like there's a couple ways to use this guy. It's saying you want to connect your clock to QA. I wonder what Q stands for in that context. Yeah, they connect. I mean, from this diagram, it looks like the resets you tie to ground, and then the clock B you tie to clock or output A. Where's our clock B here? Do we have a clock B on this one? Yeah, the clock B up here. So we don't have that tied to A. So that could be one issue. I could literally wire that together. I'd have to go into my lab, but I could just take a wire and wire those together. But otherwise, yeah, it's really just connecting the clock here. I think it's a little weird. Like there's no pull up on this port, so I think it's never going high. So I think you like you have to go high. There needs to be a pull up here. So to add a pull up there, we would need a resistor and a path to power. So we could definitely add that. That's not something I couldn't wire up and solder on quickly, but I think it's going to require a lab chip. It just doesn't make sense to me that the clock is never going high. The clock definitely needs to go high. It's not being pulled up by itself. It does make sense though, like what we're seeing. It does make sense that when you when like that this is like 1.4 or whatever, basically it's just kind of rising because the chip is powered, but you need an actual pull up to make it go high. It's just never going high. If I had two wires, I could kind of like force this to go high for a second. And then we might see an LED turn on. So that might be worth it just because it's a really easy experiment to do. Give me a little bit of faith that this might eventually work. So maybe we attempt to do that just because it's so easy to do. Conceptually, to do that, always fun getting this on camera. I think I need to attach this to like a higher stand. I wonder if I can somehow make this just go up higher. I don't know much about like focal lengths and stuff, so it might not work for the camera if I raise it, but It would be nice if it was higher. Okay, so this is the clock up here, this pin. And power pin 10 is let's see, so 8, 9, 10 is this one. Oh, it's like almost on camera. So basically we just bridge those and then we see if an LED turns on is the basic concept. So yeah, I'm gonna go for it because why not? I'm sitting here. Let's do it. I'm gonna bring this guy a little bit closer for fun. That way people might be able to see if an LED turns on. Ooh, where can I put this? I used to have a little box. Let's do this. Okay, and then I'll kind of maneuver it down. Got to get rid of this. Cool. Okay. Yeah, okay. So let's get the chip centered here. Okay, and then we'll try to bridge a wire. We have to keep this button depressed the whole time too, which is pretty annoying. Otherwise, or no. Actually, we don't. It should be fine. So let me see if I can find a wire. I think I'm slightly SOL because I just moved everything to the new lab. So that might be that might be it for the unboxing. It kind of sucks to fall short on I kind of just need a small wire, but yeah, I think my little toolbox, I just moved it over. So I don't know. I'll give this a try, maybe patch it up in the lab and then we can try ordering another, but I think got to cut the unboxing a little bit short on this one. A little bit anticlimactic. Look, not all going to be winners. Not all going to be winners. Every unboxing is an adventure in figuring out how bad things are. I do think I put a little bit too much trust in the AI, but I'll also say without schematics, it's hard to know if it's correct. So our schematic viewer is just now coming together. So it was a little bit hard to tell just from a PCB view if this thing was wired correctly. But learned my lesson. I guess always put together a schematic. And I'll go to the lab and solder this up and see if it does anything. And then maybe we'll come back with this guy soldered, and then I'll super cut these videos together. But thanks for joining. If you joined, a little bit of an anticlimactic unboxing. I'm hoping, unboxing things will be more exciting as we do Wi-Fi modules and whatnot. But that's it for now. And I'll probably maybe do some programming later. We'll see what happens. But do got to get my stream counts